Okay, hello everybody and welcome to another video in a series on pricing bonds. This time we're discussing a very specific topic, namely the convention to quote flat prices or so-called clean prices separately from accrued interest, and then only being able to calculate the so-called full price, which is the real price paid for a bond, or the price really paid for a bond, as a function of the other two. So this is an important video because this is an important thing if you are trading bonds, and I've decided to kind of go straight for a question here and explore the topic via the medium of a question, because talking about it in a theoretical way I don't think makes much sense. So, an 8% corporate bond maturing on the 15th of March 2030 is priced for settlement on the 15th of June, so that's the trade settlement date 2024, given a 7% required rate of return. The bond makes semi-annual coupon payments on the 15th of March and the 15th of September of each year. If the bond uses the 30 by 360 day count convention for accrued interest, its full price per 100 of par value is closest to, and we've got three options. Now, there's no way really to answer this question other than to try and do it in a step-by-step sort of methodical way. This is relatively long to do, so in the exam, if you're running short of time, guess this question and move on to something else where you can score points more quickly and more easily. That's my honest advice. However, if you do have the comfort of time, then by all means try and solve. Right. The full price of a bond is the price which actually needs to be paid. However, this one actually is also known as, so this is the full price, also known as the dirty price. However, the convention is to quote prices in terms of so-called clean prices or flat prices, and that's the quoted price, but it's not the price really paid. And over here in this question, I'm going to do everything. We're going to compute both the the full price, the clean price, and we'll also calculate the difference, which is the accrued interest, or computing accrued interest will allow us to arrive at the full price. The basic equation which you need to appreciate is that the full price equals the clean price, or the let's say the flat price, plus an additional component known as accrued interest. Now, as I said, both the full price and the flat price have alternative names, so this one will be also known as the dirty price, this will be known as the clean price, and accrued interest is simply accrued interest. We sometimes call this simply abbreviated to AI, not to be confused with artificial intelligence, of course, nothing to do with that. So, I'm going to, methodologically, how do you go through this? Step number one, you need to calculate the price of the bond as at the beginning of the current interest period. The problem with the bond we've got over here, or maybe it's not a problem with the bond, it's more a problem with the date on which it is supposed to be settled, or the transaction is supposed to be settled, is that, it will happen on the 15th of June 2024. And that's in between coupon payments, because coupon payments happen on the 15th of March and the 15th of September of each year. So 15th of June is somewhere in between those two. And the problem of that is, of course, you need to find a way to calculate the price as at that date. What we did previously was always the computation of a price when the bond was freshly issued or had so and so many years or periods until the maturity date. So it's much easier to compute the price on a date for settlement on a date which is a coupon payment date. Here that's not the case, and we have to do some additional modifications. So, given that the transaction happens over here, 15th of June 2024, we need to go back to the beginning of the current interest period. So 15th of March is when the, let's say, the current period started and the last coupon was received. So 15th of March 2024, and we need to compute the PV, the price, on this date. So price on the 15th of March 2024. And that's going to be, I guess, relatively easy because you know how to do that. You can use your calculator, the time value of money worksheet, to do the relevant computations. Now, the bond matures on the 15th of March 2030. So if we were standing over here on the 15th of March 2024, there would still be 6 years left until maturity. Because this bond pays semi-annual coupon, something that we practiced before, we need to make n equal to the number of years, 6 years left until maturity, but times 2, so 12. What else do we need? Well, we shall need an input for the PMT. That's the size of the coupon payments. It's 8% per annum. Semi-annually, obviously, PMT becomes 8 divided by 2. That's nice and simple so far. We're assuming an FV of 100, of course. Here everything is priced assuming per 100 of par value, and we need a discount rate, and they tell us 7% required rate of return. So for the I over Y input, we need to take the 7, divide that by 2, which will give us 3.5. And now get the calculator, not the computer. You can easily do this on a computer as well, but not in the exam. Do CPT PV, do a computation of present value, and let's see what that yields. So, like before, I'm going to get my calculator to record what's happening on the screen. Actually, it's my phone, on which I have a Texas Instruments BA2 Plus app. 12. Okay. Let me do things the right way. First of all, clear the time value of money worksheet or menu. So 12 for N. Now 4 for PMT, 100 for FV, 3.5 for I over Y. Get the calculator to compute PV, and as you can see, it yields a result of 104.8317. I'm being quite specific here. Not sure if I really need to be. Of course it's negative, but I'm omitting the negative sign. That was the price, or should have been the price, on the 15th of March if these conditions, like the especially the required rate of return, did indeed hold on that date, which is not necessarily true. But if they were true, that would have been the price. Okay, that was just the first step. What we now need to do with the value that we've got, or already have, apologies for this, is we need to translate that, or use that to compute the price, and it's going to be the full price at the settlement date. Now the settlement date is 15th of June 2024, and of course relative to March, that is 3 months on from that 15th of March, beginning of the current interest period. How are you supposed to do this? Well, this is where the day count convention kicks in, because you either will have to do this assuming the actual number of days in each month is counted, or that every month has 30 days. Under the 30 by 36 day convention, you assume that each month only has 30 days in it, and a full year has 360. But the alternative is to base this computation on the actual number of days in a month and the actual number of days in the year. That's called the actual by over actual or actual by actual day count convention, which I think is a little bit more quirky to apply because you have to know which years are leap years, etc. And to be honest, if you get a question like this in the exam, I would probably expect you to have to perform a computation based on this convention, the one that I'm using here. However, your book contains examples of both, so be sure after watching this video to have a go also through the questions, the examples in the relevant chapter in your electronic sort of online learning ecosystem, or indeed if you have the paper version of the book, please study that as well. Right, so this is the 15th of March 2024. Now, we, irrespective of what is really true, assume that the month of March only has 15 days in it. Then there is the month of April, which has 30 days in it, right, under this convention. And what is more, February would also be assumed to have 30 days in it, although it never does, right? It either has 28 or 29. Okay, the next one's May, okay, and then we've got June, but we don't care about the whole of June. We only care about the time until the 5th, and the time up to and including the 15th of June, so up to the 15th of June 2024. So the way to think about this is to count the number of days from over here when we have a price as at this date, 104.8317, and to say to ourselves we've got to inflate that price for the effect of 15 days until the end of March, another 30 days of August, sorry, not August, April, another 30 days of May, and another 15 days only of June, because that's how much time we, sorry, didn't want to cross that out, until the 15th of June. 15, 30, 30, and 15. And if you count this, you know, if you take the sum of these days, it gives you 90. Nice and round, right? If you were using the actual day counts or actual number of days, that would definitely be a different number, or should be a different number. So what do we do now? Well, we take the price that we have on the 15th of March, of course that is this price, 104.8317, and we multiply by 1 point. Now be careful here. The required rate of return on this bond we were told was 7%, and what we've got to do here is basically take half of that number, so 1.035. So 1 plus 7% divided by 2. That's how you inflate over a semi-annual period. If it was if interest was being paid once a year, you would have 1.07. But this has to be raised to the relevant power, so to speak. So over here, when raising to the power, we would have the 90 days from up here divided by essentially 180, because that's what you assume is the number of days in a semi-annual period. We're effectively halfway through the period, so that price from the 15th of March should be inflated by this factor to the power of 90 over 180. And of course, the closer we get to the next coupon payment date, the more this becomes, the more this gets closer to a full sort of number 1, and hence becomes just 1.035 as the multiplication factor. Right, let's do this on the calculator. I've got my 104.8317 still displayed, so just take the minus off by pressing the plus minus key, and now multiply by 1.035 to the power of, I'm pressing the y to the power of x button, open a bracket, 90 divided by 180, close bracket. Well, that's a half. That was easy enough. And I get a value of 106.65. That's nice and easy, and that should be my full price for the bond, or the dirty price. And if we look up at the possible answers, we see that this very much corresponds with answer B. So just to clarify, what's this? This is 1 plus the 7% of the required rate of return, but scaled by 2 to make it conform to the semi-annual period, whereas this is the effect of taking T, so that's the time since previous coupon payment was made, divided by capital T, which we typically use to denote the let's say the length of the number of days in a coupon period. In the coupon period, in the full one, because we're assuming the year has 360 days, well, 360 days, this has to be 180, and this time since previous coupon is also expressed in days. Right, we've answered the question. However, if you look at bond quotations in a professional market, you will rarely see a price that's displayed at 106.65. In fact, what you will typically see being displayed is, the so-called flat price. And in order to compute the flat price, you have to go from full price and deduct accrued interest. So, what is this thing called accrued interest? Accrued interest is simply a linear function of time and the coupon and the size of the coupon. So accrued interest, abbreviated as AI, what we will do here is we will take 4, and I'm taking 4, let me tell you why, that maybe not obvious at all. This bond pays coupon at an annual rate of 8%, but we already know that 4 is the size of the semi-annual coupon received every 6 months. So this is the size of the semi-annual coupon. And I'm going to take that and scale it for that same, factor, small t over capital T, which in our case is 90 days divided by 180 days. So that effectively, or this is small t divided by capital T, the number of days since the previous coupon was received or paid, and capital T, the number of days in the coupon period as such. And of course, this is half, just like we did before, 0.5, making the result of this 2. So this is our accrued interest. And now the price which you would see being quoted would be the flat price. This so-called flat price is simply the full price minus accrued interest. So what you would see here is 106.65. Now obviously this is not part of the question anymore, I'm just doing this to give you a little bit more insights. 104.65. This would be the price quoted, also known as the clean price, sometimes known as the quoted price, clean price. Now people who trade bonds need to take this clean price, and in order to get the transaction ready for settlement, they have to sort of manually, well, systems do this, but you have to you have to add the accrued interest so as to arrive at the proper full price which actually needs to be paid in order to get the transaction ready for settlement. And you may think, why bother with a quotation of the clean price? Well, the problem is that essentially the clean price stays relatively well, let's say it another way. If you focused on the dirty or full price, you would see that price grow pretty much every day to account for the accrual of interest. So if this is, the 15th of March and this is the 15th of September, 6 months later, then even if nothing's changing inherently, no fundamental factors are impacting the bond in either a positive or adverse way, the full price of the bond would grow because of the accrual of interest, the computation of interest. And it would only be once this date comes that we would revert back to a price which no longer reflects the upcoming coupon, because the upcoming coupon still needs time to grow. So what people created was a system for, if you trade a bond somewhere in between coupon payment dates, you will typically see the clean price being displayed, and the clean price is not impacted by the accrual of interest on the coupon, but because the buyer of the bond is the one who will fully receive the upcoming coupon, because the coupon goes 100% to whoever owns the bond on this date. But if the buyer buys the bond midway through the coupon period, they are really not fully, it wouldn't be fair if they received the whole coupon. So they will get the full coupon, but during the transaction, as part of the trade, they have to compensate the seller for a part of the coupon which accounts for the period of time from the beginning of that period until the trade date, the trade settlement date. Hence, this accrued interest gets slapped on and it becomes bigger day by day, but then, miraculously, over here, it zeroes out and starts growing again. If you had a price chart which displayed the full price, the dirty price, you would have this kind of seesaw. The price chart going up, then zeroing or falling drastically, then rising, falling, rising, falling. And if you're a bond trader professional, you don't want that mechanical action to kind of take away from the picture of what's really happened to the bond fundamentals. Hence, professionals prefer to look at the clean price, but they are very much aware of the fact that in order to get the bond ready for settlement, you need to slap on accrued interest, or there are two components to the price: the clean, the accrued interest, and that's how you get the full or dirty price.